So I just want to say good morning to everyone and thank you for joining. It is my pleasure today to introduce Joana Borrego Pinto, which is a project manager of the Swiss Transplant Cohort Study. Today, she will present this integrated digital platform developed to streamline data collection, support patient follow-up, and enable more efficient collaboration across transplant research. And with this, I would like to give the floor to Joanna.
Okay, so hello everybody. Please, I'm happy if you ask questions midway. I don't know if what's the protocol here, if you prefer questions at the end or like if people can just ask questions now. I don't care. So whenever
So
you want.
if you're okay, then if anyone has a question, please interrupt.
Yeah. And so I will give you a little bit of a ride over like what we do and like the different things. Maybe about some like ideas about project management. I will probably talk too fast if I get too excited. So I'm also happy if you tell me to slow down a little bit. If something is not clear, just let me know, and I will just go for it. So first of all, I will. So this is basically my plan here. To give you a short introduction about the Swiss Transplant Cohort Study, STCS.
We cannot hear you. I think you're muted. I'm so sorry.
Oh, interesting. Okay. Okay. So I was saying that basically I will give you a little bit of a short introduction about the STCS, so the Swiss Transplant Cohort Study. And then I will also show you a little bit about the different applications that we have developed across the years. And I will maybe go a little bit more into detail into the one that I was more directly involved. And then maybe also mention some of the things that we do in terms of project management. I mean, here I know that the audience is quite broad, and so I just thought to give you some idea of what we do, at least, or how we do it. And then, yeah, questions anytime. It doesn't matter too much to me. Okay. So then next, I will first give you a little bit of an introduction about me. So I am not really a technical person. I did biology most of my life, molecular biology and genetics, more specifically also like cell biology later on. And so I'm Portuguese. I come from Lisbon. I did my bachelor's and my master's at Lisbon University. Then I moved to Paris to do my in Erasmus. So it was an Erasmus year, but I did a master thesis there in the Institut de Virologie, so like in cell biology, nuclear movement. Then I did my PhD in Heidelberg, also central elimination, cell biology, pure basic biology. And then I moved to London to do my postdoc. There I worked with polarity and C. elegans, but it was also where I learned how to code. So I did some R, and actually Maria was a very pusher in this regard. Like you should learn because it's important. And then I actually realized that it was actually quite cool. And from that moment on, I thought, okay, maybe this could be something that I would like to do in the future. And then I moved to Basel, and I was trying to go more into this direction, more data science. And so now I'm a project manager in the STCS. Not only project manager, so I also do a bit of data management. And I'm happy to also discuss things if you want. And so I work at the STCS, as you might have understood already. So the STCS is like again Swiss Transplant Cohort Study. So we manage the data of the patients and across Switzerland. So there are like several centers that perform transplants. So in Basel, in Bern, Lausanne, St. Gallen, Zurich, and Geneva. And so we kind of collect and manage all these patients. And interestingly enough, also in Switzerland, once you get a transplant, the patients have to be followed by law their entire lifetime. And so what we do is then kind of follow them, and but also kind of collect all the information regarding transplantation, also diseases, diagnosis, and then try to make it kind of a compendium in a unique database system, and then make this data available for researchers if they want to ask questions. For example, like which bacteria are more common when you have a transplant liver versus heart or whatever, something like this. So there is a lot of kind of data that is aggregated, because you can imagine that it's like along the lifetime of a patient. There are many patients, there are many centers, and so this is what we do. So of course we are kind of a different background of people. So my team is specifically the data center. So we are responsible for managing this data base of the patients. And that's why also we kind of developed all these applications that I will talk about later. So this is just a team. And again, I'm not a technical person. I know more than what I did before. But if you have too many technical questions, maybe I will not be the best person to answer, but I can try anyway. So please just let me know. So we are kind of a relatively small team, a bit of a mix between project managers, statisticians, and also software developers. And of course, what I'm going to present, it's a work of many people and many hours. So buckle up again. So just to give you a little bit of an idea and the overview of what kind of data do we deal with. So I mentioned that we have different institutions. So again, different hospitals, which have different patients. So again, multiple data providers. We also have multiple data sources that we have to manage, because in this regard, so it's a lot of sources, but for example, is the identifiers that we get from different registries. So either the study registry, that because the patient will have an identifier which doesn't identify the patient himself, but it's just a person in the study. We also have identifiers from the Swiss Organ Living Donor Health Registry. So this is basically where the donor ID, and also then the organ allocation system. So there is also, like, every time that you have a transplant, you have a certain ID for the organ that is being transplanted. And of course, all this information has to be matched properly to the right patient. And then I also mentioned before, because we also follow the patients over time. And this is basically every time that this patient comes to the hospital, there is a source of data because they perform exams. But it's also when they get the transplant, they also get a history. So like what kind of diseases they had before, what kind of problems they had that maybe caused the transplant, what kind of problems they will have before, because you can also deal with rejections and so on. So there's like a lot of different layers, health layers, and also healthcare data associated with this. And then also we follow the patients with a certain frequency, so every 6 months initially, and then yearly. So again, all of this generates a lot of data. So to deal with this, this is just like an overview of like the different apps that we created over the years. They have different functions. I'll explain you a little bit what things did we do and why, and also of course evolution. So things that were maybe done in the past are like getting improved, or they are also changing over time. So I will also mention this a little bit. So the beating heart, let's say, of our team and what we've done, it's basically to create this unique database. And so this is a 3LC. So we call it 3LC because it's like 3 lines of code, because it's easy as 3 lines of code, which is not, but we kind of try to keep the spirits high. And so this came to substitute our previous database, which was CMET, which was quite not very good. I'm actually not even from this time. I've seen it briefly, and it looks like a nightmare. And so associated with the 3LC, you also have a code book, electronic code book that basically describes the variables and helps then to kind of create all the labels that are inside the system. And then this can be updated over time, and also you can keep track of the variables and so on. And so it's also a way to make the data fair, and we're also currently improving it to make it even better. And so the idea of this 3LC then was to create this one platform where you have all the data of the patients. It's also important to know that I'll mention this later before, but up to a few months, the data that was in this platform, because of data protection of the patients, were introduced manually by part of our team, not my team exactly, but the other people from STCS as well. And so then, which you can imagine is also a lot of work. And then all of this is organized. I'll show you how it looks like. And then we provide this data for researchers. So if researchers want the data, they contact us, and then we provide the data for them. And we also can help them with support, statistical support, for example, and so on. So this is like a print screen of like the test version that we have. And you can see basically all the information that you would have at 3LC. So you have the patient here, for example, you have information about the consent, about the date of birth. You don't have the information about the name, because again, that's like private, and everything else that would identify the patient, so address and so on, is not on this database. You have information about the center where the transplant was performed, and also all the transplants that were performed. You have then, for example, in each visit, what data was generated, the donor ID that I mentioned, the organ ID that I mentioned. Also over time, you have the diagnosis, so what brought the patient to have a transplant, all the drugs that the patient has taken or will take, lab results. So you have many data for each thing. And then again, so this, in this case, it's a fake patient, so you got 4 transplants, poor thing. But you also have then information between the different transplants. So again, lots of data to deal with, and sometimes, so it's just a way to make order out of like chaos a little bit, and structure. Because as I mentioned before, like most of this data has been introduced manually, so of course humans make errors, and sometimes also because the system is itself evolving, sometimes you have to kind of understand things that need to be corrected. So for example, if before a null value was NA, but now we write it in some other way, empty, for example, just because of whatever, then all of this has to be corrected afterwards. So like now, associated with the 3LC, so our database, there is a system of query control. So like where we write queries and we kind of try to understand if values have to be corrected. And sometimes it can be from like the date of birth was mistyped, to, for example, there's problems on the organ donor. Of course, the amount of mistakes that happen, it's limited, but they do happen. Or sometimes, for example, we have in the system by mistake different ways of recording pregnancy. And if someone wants to understand what's the I don't know, the role of the if pregnant women had more problems with certain transplants or whatever, then of course this is also data that we can generate, but it has to be curated somehow and properly organized. So this is also part of what we are doing in the system. Okay.
Joanna, there is a question. Is this connected with the SPHN, which I'm not sure what it is?
So the SPHN is the organization of in Switzerland. So it's a funding agent. And yes and no, in the sense that this part that I showed, it's not really related to them, but we had a project that I'll talk about later that was funded by them partially. Yeah, so I will mention more a little bit this, but I think it's so one of the aims of the SPHN is really to kind of make data more accessible, so patient data more accessible and easy to use and fair. So it's a big topic in the moment. And for example, they actually helped a lot for our project. I will mention this later on, because they also funded the data warehouses of the hospitals to make them fair so that it's much easier than to retrieve the data. So that's why I say yes and no. And please let me know if there are questions, because I actually cannot see if there are questions on the chat because I don't have the chat activated on my computer at the moment. yeah, but so happy to answer anyway. So again, the next set of applications that I will mention very briefly, it's a little bit, so there are different sides of it. So for one side, I mentioned that we also help researchers and support them. And so, for example, before we had a system to keep like record of the different projects that we have in LabKey, and it was also not very user friendly. And we also want to make it a little bit more streamlined in terms of like the users can follow the project and so on. So now LabKey will be substituted by the STCS Universe, so which is a project management platform, and it's ongoing. So I'm talking a little bit about its present, future at the moment. And then we also have other applications, for example, DigiCore, it's a password management platform, because as you see, like each one of these applications will be password controlled. And so if you have many applications and you have many passwords, so like we are trying to kind of centralize it so that also it's easier than for the users to not have 1,000 passwords, but because we get a lot of requests about, I lost my password, how do I reset it, and so on. So it's also to help this. And also we are developing, this is not yet done at all, so the SEP, which is mostly for the patients, in the sense that it's a secure portal for patients to log in and identify themselves, and then they can self-report. So for example, we also have questionnaires that is like self-reporting questionnaires. So how do they feel, for example, in terms of pain, in terms of how active they are, how able are they to have physical activity. And so normally they report this in the when they come to the appointments, but then they can just do it themselves at home, without the judgment of a doctor if they want. Not that the doctors judge them, but it's just more comfortable for the patients. And so all of this, so we aim to then kind of just facilitate the research, facilitate the communication between the patients, facilitate everything. So that's at least the aim that we want to do. So now this is the project that I want to talk a little bit more in detail. And so this is the things that I was more involved. And this is the one that was partially funded by SPHN. And so here I also have to mention that there is a little bit of a evolution, in the sense that it started with Ideal, and so Ideal is a kind of a key management system which links the hospital ID of a patient to the study ID of a patient. I'll show you a bit more about this. And then we had Chill, which was a way to then retrieve the data from the data warehouse from the hospitals. And now we are combining them into one product. So that's the part that we are currently working on it. And here the main aim, and I'll talk a little bit about this, but it's really to reduce this manual entry that I mentioned that we still do in our database, and also then to increase the amount of data that we can retrieve automatically from the data warehouse. And then, of course, also increase the amount of research or the available data that we can offer for researchers. Yeah, so I'll explain you a little bit more the context now. So the thing is that, and I'm not sure if this is obvious, so I apologize if it is, but basically, for people that are maybe not so familiar about this, there is a little bit of a problem when you want to retrieve the data of the patients, because the patient identity has to be protected, in the sense that you cannot really show to which patient, like what you cannot really kind of attribute the data to a specific patient, so everything has to be anonymized, and so because otherwise also the patients would not consent for their data to be used. So there is a bit of a problem, and like as a researcher and as a court, you have to be careful about this. But then what happens most of the times is then you have a lot of data inside the hospital which are identified. So like inside the hospital, you have the real personal identification. And then you have the court registry, the databases of the courts that have the pseudonymized data, so the no identifiable data. But they want the data of the patients, right? So, and what happens in the end is that this data is manually introduced into these databases, which is a little bit silly, because clearly if things would be connected, everything would be better, and everything would be a bit streamlined. And what happens then, it this create also huge problems in terms of like access to data for researchers, because you also need people to actively type this data. It's also not very pleasant for them. And then of course, you also, most of these registries, it's a bit, you have to be careful that the patient identification is not revealed. So like, how do you manage this? Because sometimes you have both systems open in the same computer, and of course then if someone else comes, they can see it. So there are like a few problems associated with this. And so then what we are trying to solve with Chill is really to kind of release the data that is in the hospital, and just make it automatically into the data entry, respecting the identity of the patients, making things much more effective for researchers and for the staff that don't have to introduce this manually anymore. And so it's just a very simple idea. So basically, we have this tool that then kind of creates this linkage between the study ID and the personal ID, and so between the hospital and the study. And there's also a problem with the hospital firewall, because everything is kind of contained inside the hospital, so you cannot really access it directly via the network. So there is also this problem. And so we have this tool that runs strictly inside the hospital, but you can, via smart linkage, I'm not going to too much into the details, you can then kind of find your patients automatically into the database, connect them, keep them connected, keep them protected. And we have also already this tool in different hospitals, and several studies using it, and different users as well. But it's just basically to really create the connection that is missing between the hospital and the research study, and then facilitate everything else that I will explain afterwards. Because this is the point. So then you have, once this connection is made, then you can easily extract the data for these patients automatically. So like, that's what the role of Chill here. And then of course, the data that is extracted from the hospital will not have any identifier from the patient anymore. So this is all removed from the data. And then what also Chill does is that it also integrates data from multiple hospitals, which it's relevant for us because we work with different centers. And then it also provides then this automatic feeding, let's say, to our own database. And of course, this brings great value. So I can just show you some of the numbers. So for example, in terms of data integration, we got huge amounts just for like one single transfer, sorry. And also in terms of manual data entry, you can see that without Chill, you have like an increase of like fourfold. And that this is like, again, only one data transfer that we did already. And so everything is a little bit easier, let's say, and more accessible, and just facilitates everyone. Then one thing that we also want to do with Chill, and that we already implemented, it's basically because sometimes like researchers want to make a study, but or want to understand if they have, for example, enough patients for a study, but it's again hard to like understand the data in the data warehouse, or maybe like ask the question. So maybe they have to request data first to then understand if their idea is feasible or not. And then there's also, of course, the problem that most of the doctors and a big amount of researchers, maybe they don't really have the coding abilities or technical abilities to ask these questions themselves. So what we also want to do with Chill is just facilitate all of this. And so, and basically developing this querying system that is inside the hospital, and that allows then the researchers to ask questions about the feasibility of studies, for example. And we have different types of queries in this regard. And I'll mention, for example, of course, we are using AI now as well. And there's basically this interaction with the AI agent that allows you to kind of easily ask with normal language about your data. So for example, here, I just asked about creatinine tests for a certain patient. And then the AI agent will ask me, so what patients do you want? what time frame do you want, what kind of tests do you want, and then I reply, and then basically I say, okay, so do you want all of this? And I say yes, and then you will write the query based on my answers. So like, and then you will browse the database, the data warehouse of the hospital based on this. And this is, for example, like a preview of the different patients that you found. And this is the query they generated. And of course, this is also kind of controlled. So like not everybody has access, so that we also are careful with this, of course, so that you have to, there's some rules and some like login access that is prevent, like you need to be able to access to be able to do this. It's not like everyone can do it, but it's just a way to then kind of easily query the data. And again, it really removes the technical ability, the technical need for this to happen. So that's basically this. And so then with Jill, we are trying really to kind of help streamlining research, streamlining the power of the simple user that doesn't have technical abilities or less technical skills to do it. So like basically based on the patient selection, patient retrieval from the hospital, then the data extraction directly from the hospital, the integration from like their database to the core database, and again then the easy query of the hospital data warehouse, so that you can think about your studies on your own time and without having to suffer too much with it in terms of, because you don't have the technical skills. Okay, so then basically this is the kind of the summary of our app. So we are really trying to kind of bring together users, patients, research, and that's why I think we are like trying to improve things in different ways. And of course, it's a working in progress, so it's not completely done yet. But I think you realize that basically our team, so when I say my team is like the DC center. I mean, we have like 4.5 developers, and they are working on all of this. And it's of course hard to sometimes understand the priorities, manage their time, and manage all the apps, all the deadlines, and so on. And so we have a little bit of like what ways of dealing with this, and I can explain you a little bit how we do it. And so I think,
Joanna,
yeah.
before we proceed to the next step, there is a question by Marco. Do you know if ideal your privacy preserving record linkage solution is a custom solution or if it is based on some standard? And then he mentions adoption and good implementation of a common PPRL solution for all rare diseases resources has been a challenge.
I mean, so we developed this in-house. We are actually trying to, I mean, we have non-negotiations. We have conversations with people. So kind of really telling them to adopt this because we know that the problem exists. So we are mostly focusing in Switzerland at the moment. But I would be happy to, if you have questions about this, we can maybe further discuss. Because I mean, maybe the common thing here is that I know probably the problems that you have is problems that we have as well. And so I think I'm happy to further discuss this if you want, and maybe find a common solution. So at the moment we offer this, I mean, it's a free application, and we are still kind of trying to understand. Of course, it has limitations because of this. But yeah, I'm happy to discuss further about this, and maybe we can also involve my boss and so on. So it's to understand a little bit your use case, and maybe if we could provide a bit of help. In the end, it's a little bit. I mean, it's a simple tool that just links the two things, right? But then I think the beauty of it, let's say, is that there is actually a similarity score calculating the matches between the information that you provide from your study and the hospital, and that's kind of what helps them to bind the two patients. Well, the personal information, the pseudonymized information. but I can provide more information, but maybe let's see later. Maybe I'll provide my. So I'm happy to also further have a meeting afterwards or something like this.
And I've also raised my hand because maybe it's something we can actually do in the context of HemaFAIR, because we have this issue in rare disease in general, and we have the issue in almost all the projects that we're in. I'm very happy to say that our friends in Cyprus, you were able to manage to get the spider system implemented, which is a major problem for a lot of rare disease registries. But so we know an expert group in this in Austria.
Okay.
And I wanted for another project, I wanted to reach out to them also, but maybe we can in HemaFAIR, maybe this could also be a webinar that we actually invite these people from AIT in Austria, and that all of us who are using some kind of system to do this can join it. They're scientists of this topic, so that's they're valuable information if they're willing to do that. Yeah. So maybe Soti, maybe we can follow this up on. Maybe we can do this in the context of HemaFAIR.
Yeah, definitely.
I would be very happy about this as well, because I am against reinventing the wheel. You know, I think I'm more about sharing information and trying to kind of make, work together. I'm very happy about it.
Yeah.
So
the system they have built themselves was also relatively successful. That's very sophisticated. And what I've learned from others in practice, it can fail, not their system fails, but if people then do not provide consistent information at the source from which these identifiers are generated, then it still fails. So it also takes good citizens to be able to make it work. So this, but it's something, we need this for rare diseases desperately. So it's, I think it's worth spending
Since it's a common
on.
challenge for everyone, it would definitely be interesting to look further into it, what others have done. Thank you.
Yeah, that would be cool. Even for me. So sign me up. So I'm happy to join. Okay, so now I carry on. Unless there's further questions, maybe I should have asked before carrying on because I was on the go. Okay, we'll see. I'll continue. So here, this is the part a bit about the project management. So we use GitLab a lot. So that's how it looks like. For every single project has their own GitLab, and so kind of all the issues are managed individually inside each project. And so there's a lot of value for every single person that is part of the project. So for the software developers, it's also a way to, again, I'm not sure how many people know about this, so I will try to include everybody in the description. I'm sorry if sometimes it's too much information or too basic information. So I think for the software developers, so it's a way to also kind of manage your code, kind of branch, merge, all of this kind of. Also, you can share the code and just see to each other who did what and keep track of everything. So for the project managers, I will mention these topics a bit further ahead. So you can organize the milestones and the epics. You can just manage the priorities, and I'll explain you how we do this. And then also for everybody involved, you can really design the issues, which are here the tasks, let's say, and then you can really clearly assign who is responsible for what. There's always comments associated with each issue, so people can talk and everything is kept in one place. You'd also have wiki associated with maybe the technical part or everything that is related to the project that needs to be documented. So it's really a huge source of information that we use every day, and everybody uses it. So I can, for example, explain you a little bit how the issue works for someone that doesn't know. So it's very flexible. So here, for example, I created the issue about making a cake. Of course, it's not part of any project, but so anyone can create the issue in principle. Normally, depending on the issue, maybe if it's a technical issue, maybe the software developer will create it. If it's a more user reported a bug, or I was testing the system and I saw a bug, then I kind of report the issue myself. Depending a little bit of the style. So I think, but everybody is free to create an issue. Then the assignment is also a little bit anyone can do it, especially if it's a technical thing. Normally the project manager will do it, but in a sprint meeting that I'll mention. But I think it's also flexible in this side. So one thing that you can also do is like to keep track, for example, of the dates. So when you started and when it's supposed to be done. So in terms of deadlines. So it's also very handy because you can create a checklist inside the description, for example, if you have different steps, or you can also create child or subtasks, which is here the child items, and it's kind of the same feature. Then you can assign them to different people. Here it depends a little bit on the workflow and how many people are working in the same issue. You can also link items. So for example, here, if something is associated with another issue, then you can just add it here so that everything kind of is connected, let's say. Then other way is kind of quite handy is, for example, to have these issue boards. So these issue boards are flexible and they are like created by normally by the project manager, and it kind of follows a little bit the flow of the resolution of the issue. For example, here is a simplified version. Okay, so like if it's ready to be reviewed on the test server, if there's problem, so it was opened again, if it's ready to be deployed into the prod server, if it has been reviewed, and so on. So there is like kind of, it's a bit of a checklist, and like you can just drag and drop for each container. Normally for software developers, this is very good because they really see the progress. They can kind of target, they can mark it as doing or to do, and also for the flow, and then also for the issue resolution. So it has been tested, it has not been tested, it is on the test, it is not on the test, it's on the prod, whatever. And also you can create a set of labels, and this is again all flexible, so you can really be tailored for any kind of project. So for example, you can have this is how you decide also the priorities. So you have different categories. So for example, low priority, medium, high, urgent, and so on. And then you can just add it to the issue, and so it's also an idea of like what needs to be done first, let's say. And then again, you have this different labels that then you can create this issue board, or you can just create topics, for example. So like if an issue is related with a bug, then you have a label with the bug, and so on. So it's really like, so for example, here, this is something related with 2 hospitals, and so you can really like go wild. I like labels a lot, so I mean, I use them a lot. But of course, I think it's a bit of a team decision how many labels you use, but in the end, it's a lot about to help the flow of the software developers, but also the project managers. So then we have a sprint meeting, and I'll tell you the frequency after, but what a sprint meeting means is that there's like kind of a collection of issues that are assigned to a specific sprint meeting or milestone. So GitLab, we call it sprint meeting, but it's the same as the equivalent of the milestone in the GitLab. And again, you can kind of so it's normally kind of a specific period of time, so maybe like 3 weeks or 2 weeks, in which everybody works in a specific amount of issues, and there is a certain aim. So for example, you want to finish this feature because this one has to be released like in 3 weeks or something like this. And so this is normally, well, you have a title, you also have a start date, a due date, a description, but then you have a pool of issues that then the project manager normally will organize into different milestones. And then during the sprint meeting, the team also decides on final priorities based on like maybe the work time that the software developer has, because he also is working in 5 different things. So if one thing is urgent, then he will give priority to this, for example. And also the project manager will also know what kind of priorities you have based on the deadlines that you have. So it will also prioritize the different workflow. So I think our style of project management is a bit agile, but like in an agile way. So what we do is basically we have then the sprint meetings. They are self-contained in the sense that it's a certain amount of issues, and normally it shouldn't be changed during this certain period of time, which takes about 2 or 3 weeks. And of course, if there is something urgent because there is a bug, then this will probably be added. It's also flexible in the sense that if something is not done for whatever reason, then it will kind of maybe carry on to the next milestone, or things can change, of course, priority between milestones. And so this can also be reshuffled a little bit, but it's a way just to kind of focus the work of people, let's say. And then every day we have a very short meeting about kind of discuss what each software developer will do that day in terms of, what's the focus. I mean, not without many details, okay? Just the focus of the day. And if there is something urgent to discuss, then it also happens there. If something needs a further discussion, then this will be booked into a different meeting. So it's again flexible. I think it works for us because I think then it kind of keeps us in contact with what needs to be done, and there's quite a bit of a discussion, so everybody's aware of what's going on at all times, which is nice. And then we also started, because again, so I mentioned that we have all these different apps, and so what's happening at the moment is software developers are working different of these applications. So at some point it was becoming a bit messy because we were kind of fighting for priorities and so on. And so what we did is I think this is actually very, very good. So I recommend to do it if you have a small team, many things to be done. So which is a Kanban project. So we sat together and we defined like the big priorities of each project. And then together, in terms of the time, in terms of the deadlines, in terms of priorities, we defined what would be the thing that would be done first. So here, like each project is a color, and then you can see that basically not everything has the same priority. So like all the things that are here are things that I have higher priority, and then we also keep track of what's been done. And I think this is very good also because to facilitate communication, because then if you know that a person is the software developer that is working on your project, but at the moment it's like there is another priority in the other project, then you just leave them in peace, so like so it's a good way to just really be clear about what's currently been done. And Maria, yes, I see you.
Yeah, I was going to ask whether these tasks here and the priority lists on this board, like with the sticky notes, is also replicated in GitLab, or whether it's completely separate, so you can, it is replicated, it's just the visual representation. Also,
okay. So in this case, it's a little bit more like a higher vision. So here we basically defined epics, which is like the big milestones of the year. So like what are the things, the big topics, and basically each epic then will have several issues associated with it. And then we also define this on GitLab, and basically and then inside the GitLab, basically there is specific issues associated with this. But then, so for example, I don't know, let me give you an example. So for example, for chill, if we need to have another hospital on board or something like this, and this is the highest priority at the moment because this depends, everything else depends on this. Then this will be the top priority of the project, let's say, and we'll make it to the to-do board. But then depending on, and this has to be done in 3 months, okay? So this is also the kind of this happens every 3 months, so we define the priorities every 3 months. So if this has to be done in the 3-month frame, then it will make it to the to-do board, and then accordingly to the other projects, then we will kind of prioritize it accordingly. So like, okay, this can be done at the end of March, or this can be done at the beginning of February, or something like this. So, but I think it's really just a visual way. But yes, so everything, I mean, you cannot see it here, but basically every epic then has its own issue created inside the Git. And again, issues here is a very flexible term, right? Because it can be an epic or it can be a simple task. but it's just how you organize it in the end and how you label it and so on. So like, for example, I also, in my case, I created each epic has its own milestone. So then you can I have all the issues associated to this with labels and so on. So it's a little bit like play it around and puzzle around and see what works for you and for the team that works with you. So, and I think this is kind of important that you also have a conversation, and just sometimes things don't work right away. So it's good to just like, okay, is this working? You know, a bit of a wake up call. Is this working? What can be improved and so on, and just try to find something that works for everybody. So it's a bit, I think what this Kanban board also helped to do. Yeah, I hope I answered your question.
Oh, yeah, yeah, thanks.
Then other things that we also have, so like, I don't know, I don't think you saw, we have, so normally the more technical documentation or the more the documentation related with the project itself is that is more private, let's say. It's inside the wiki, inside the GitLab. But then we also have a user documentation that is available to the public, and this is done. I just thought that I'll mention it because it might be relevant. So we use this read the docs tool that is associated with the GitHub, and so it's a very easy way to build documentation. It has some pre-formatted things. It's also free. It can be accessible from everywhere, and multiple people can use it, and just also a way to kind of maybe help the users for the different functions of the different things that they have to, if they want instructions, for the certain features of functions of the application that you have. And that's it. So I hope I answered questions. Well, I already answered some of the questions. I hope it helped and you learned a little bit today, and I'm happy to take more questions, of course, now.
Thank you, Joanna. It's super interesting. I really think like it's a base for the electronic health record that Europe is trying to make, or many projects that try to digitalize and help research. We had some questions. If you have some questions, please raise your hand or post it in the chat. I have one question. Is the code book openly available? Is it open access, the one that you're using?
So at the moment, it's only available for the users of STCS users, so some kind of members, let's say. So it's not fully available for the public. But I think we are actually supposed to make it available for everybody. So I think in principle, everybody can access it, but it still has to have a login account. But yes, we are also restructuring this a little bit, but I think it's mandatory that we make it available for the general public.
All right. And do you know what standards for the vocabulary were used? Were there custom made, or are you using some ontologies, if you know?
So mostly custom made. I think now we are trying to integrate ontologies. So that's one of the things that we are trying to do to make it more fair.
I see. Thank you. Does anyone else have a question, Petros?
Thank you. Very nice presentation. So you presented a high number of applications that are mostly custom-made, in-house development, which is quite impressive, of course, but I guess it makes sustainability a bit more difficult for those tools. How do you manage to keep them, for long time? Because it would be easier, I guess, to use existing software and existing tools and build on them. That would make sustainability easier. But how do you manage to keep them up and running?
Okay, so I would say yes and no in terms of sustainability to use other sources of not custom made, but like publicly available. Just because also these tools, they also sometimes the company closes, right? So it's also a little bit of a problem. And for example, I understand what you say, and I think in the end we ended up doing a lot of custom stuff just because of the type of data that we have. That is a little bit kind of complex, and I think initially when they decided to create the 3LC, they I mean, I was not here yet at the time, but as far as I understand, they tried to see if there would be like databases that maybe we could just adopt, like already made, it's kind of maybe REDCap or something like this. But I think the type of data that we had was too complex for what was available at the time. So that's why they decided to kind of just make their own. I think then in terms of sustainability, of course, it's a problem. But I think because we are like a cohort that is actively using all of this, so it's not that we are kind of keeping things that are not being used, and you've seen that they really evolve as well over time. So I think here in terms of we are keeping them sustainable, let's say, and basically really like keeping the things that are important and really kind of trying to tailor them to what we need. And I think that's why also we are trying to expand a little bit to other people, because then we hope to make to make it useful to other people as well. But then also if more people use it, then we hope to maybe get some funding and then kind of also improve the sustainability of these apps. So that's a little bit this. But I think some of the things that we've seen, so the step that I mentioned, which is just like login for the patient identifier, I think there are some things available, for example, in REDCap as well. But so in Switzerland, sometimes they're a little bit strict in terms of legally. And for example, and in terms of what the ethics committee allows and so on. And we had several discussions with several people about this. And I think REDCap has quite a few flaws in this regard in terms of identification protection and security, which I think our app would help with. And so that's why people are quite excited about it. And we started working on in this regard, because I think it fixes a few flaws in this regard in terms of like the way that we save the information. Don't ask me too much information because this is like the technical part. But I know from the software developer that basically we separated the different the login information of the patient with the identifiers and so on. So it's not possible, and everything is encrypted, and it's not possible to kind of retrieve the information if someone enters inside the database. Inside the breaks inside the database. So we think a lot about this, and I think we discuss a lot with a lot of technical people. So we always try to make the best decision, let's say. And of course there are limitations, because it also means that we are slow. But I think that's it.
Thank you.
I hope it answered. Too much information, maybe.
Do we have any other questions? We're close to the time. Seems that we don't have any other questions. Thank you, Joana, for your time and for accepting our invitation. It was really, really interesting talk.
Thank you for having me here and for listening and for the questions. Yeah.
And I'm sure we will be in touch with the Marco question for perhaps future talks.
Yeah.
And I just want to say we're going to have a webinar on the 9th of March by Divisor. This is the next webinar. But for the moment, thank you, Joana, for the great presentation and your webinar. And I'd like to wish everyone a nice day ahead.
Okay, thank you. Bye-bye. Have a nice day.
Thank you. Bye-bye.
Thank you, everyone.
Bye-bye.